So in this particular question here, I have a positive charge of 3.2 right here, and I have another charge right here that is negative 6.4. And these here are going to be 42 centimeters apart, so 0.42. Now we're looking at specifically at spot P, which I'm going to put about right here, and spot P is 0.15 meters away. So what this really is two questions. We are looking, now if we have a particle at spot P, we're going to see a force as a result of the interaction between whatever that spot P and the 3.2. And we're going to have an interaction between spot P and the negative 6.4. So this means we need to make sure we keep in mind that this is 0.27 meters away. So now let's go ahead and let's do these calculations. We'll spot number 1 first. So we know our formula here is going to be kq over r squared. So k is the constant, so 9 times 10 to the 9. The charge we're looking at number 1 specifically is 3.2 times 10 to the negative 9. And the distance between them is 0.15 squared. So when we go ahead and we plug this into our calculator, we end up with a value of 1.3 times 10 to the negative 3 newtons per coulomb. And this is going to have a direction. So in this particular case, we're going to have this go to the right. Now, how do we know it's going to go to the right? Because we said that point P is a positive charge. So there's going to be repulsion there. If we look at spot number 2, it's going to be the same equation. And yet again, the force is going to be to the right because P is positive and negative 6.4 is negative. So attraction will be occurring. So yet again, it is kq over r squared. So 9 times 10 to the 9. I know it's negative 6.4, but I'm just going to write in here 6.4 times 10 to the negative 9. I don't want to confuse myself with the signs right now. We know from common sense that it's going to be attraction. And this will be 0.27 squared. It will work out to be 7.9 times 10 to the negative 2. Or sorry, 10 to the 2. My bad. Newtons per coulomb, yet again to the right. And yet again, that should have been positive 3. So now, P is going to be experiencing the two forces. So if I want to figure out what it is happening to point P, the sum of the forces will end up being what we found for E at spot 1 and E at spot 2. Both of these are adding together. So 1.3 times 10 to the 3 and 7.9 times 10 to the 2. And when I work that out, I end up with 2.1 times 10 to the 3 newtons per coulomb to the right.